Hello everyone, it's time to continue learning Rust with rustlings. Last time we were stopped on iterators, and I would say it was hard. Actually, like had me thinking, you know. And the problem we had was on this exercise. So we need to return a result that has an array, and like this is I think what we're given, and kind of was thinking about it, and the problem I think is I kind of overthink it, and we should just return a vector there, so like this, and then we can just call combine. Oh no, not combine, collect, sorry. And it should work. Okay. And the same thing should happen here. But this time we're gonna return a vector of results of I64 and division error. Nice. Oh, what station? No, it's result, not results. Again. So we need to return something, of course. And how we do that? We do collect. That's it. It's pretty easy actually. And we don't need to assign a variable, we just need to return it, right? This should, yes. Let's check out the solution, by the way. Solution iterators. This is the third exercise on iterators, so we need this. What? But we just solved it. Okay. So what they did, yes, they used the vector. Okay. Well, like this kinda, I think they should have explained it more, because I thought you need to return like fixed sized array. Like you can do that in a C or C++, I think. But apparently not that easy in Rust. Okay, they just use collect. So we are good, we are good. And they did basically the same thing we did. Let's move to the next one. Okay. Complete this function to return the factorial of number, which is defined as, okay. Not use early returns. Try not to use imperative style loops. Additional variables. For an extra challenge, don't use recursion. Okay, so can use a loop, what? And we can't use recursion. And we can't use early returns. As in, don't use the return keyword. Okay, so I mean, so where is an iterator? So I think it's gonna say us that we need to use an iterator. But for us to do that, I think we need to read a bit more on iterators, right? Can it like what? This is so dumb. I actually opened like an incognito window, so it's like not maybe accidentally open some kind of website that has my data in it, you know. But apparently you can't stack like regular incognito tabs. Whatever. Like, to be honest, I think I should just do that. Like, just close this and just do that. Okay, so traders. So let's get character next. I think we should create an iterator. But I think that's kind of too much though, not? Like, I don't know really. So if we have 0, it returns 1, right? And if we have 1, it returns 1. So I think what so it's factorial, right? So it uses the index. It uses the index. Okay, well, we could do something like that. So we have a number, right? And this is like an index. So I guess what we can do, we could create a vector like this, and it will have its vector of ones. It's a vector of ones, and this vector, it will have number plus 1 elements. Yes, and then we're gonna use iterators like this. So we're gonna return v vector. Then we're gonna do reduce, or not reduce. I think it was. We can do like collect for now. Should work though. No, it does not. Okay. So we have. We should just kind of Google what we can do for an iterator. I forgot because what kind of methods do they have, to be honest. There is next, we don't need next. We need we don't need flatten. We should need something like reduce. Yes, but not reduce, we need fold. Yes. Or do we though? What's the difference? Oh, we can do like reduce. Okay, by applying a reducing operation. So we do like reduce, reduce, and then we have, I would say, like factorial, and then we have a like index, right? Or not the index. Man, it's hard though. It kinda is, to be honest. To be honest with you. Can't do this with iterators, but kind of thinking like, how would you do it? What do we have? Position. Searches, we don't need that. We don't need that. Size. Iterators, they do have a size. Don't use recursion. So we're going to use an iterator. And somehow we need to make it. But iterator does have a size, right? Right. And the size gonna decrease. So this is gonna be an iterator. And it's gonna be like this. And what we're gonna do, and we're gonna do it like this. And so expected use size. Wow. U60, so it can do like this. Interesting. Basically, I think so. U size, it could be less than U64 on non-64 systems, right? I mean, it is unsigned. It's U size, and it should be 64 on 64-bit systems, but it's not on every system. It's kind of interesting. It kind of feels like we wanted to like create an iterator, right? Like our own iterator. Yeah, like it feels like we wanted to create an iterator. Smart pointers, concurrency. Yeah, I think it's gonna be like too advanced for what we're trying to do. It does give us a link to iterator documentation. So maybe we actually should make an iterator. All right. Yeah, maybe. Or do we? Do we though? So I don't know. Maybe you should try. So we can make struct. We can make struct called this could be counter. This could be counter. But when we create an iterator, it should be we want to call like Fib sequence, Fibonacci sequence, something like this. And we're gonna have like index, but it's gonna be like have like num. It's gonna be x64, and it's gonna have like let's call index whatever. Or maybe like current. And then what we do? We do methods for this Fib sequence. It's gonna be like new. And gonna have an basically U64. And then gonna return. Why can't I like return cell? Maybe that's not how it is. Maybe it's gonna return like this. No, it's not gonna work. Should work though. We basically like create a new like this. Number gonna be like num, and current gonna be 0. Okay, okay. So then we implement iterator for Fibonacci sequence. Why am I saying it's Fibonacci sequence? It's a factorial, right? It's a factorial, guys. It's a factorial. Yeah. It's factorial. This is a factorial, this is a Fibonacci sequence. So what does factorial has? It has number, it has like current, and it should have a result. Okay. So we have this result is, what is the other result? The result is 0. It's fine. And current is 0. Okay. Can we implement an iterator or factorial, which what it's gonna do? The counting with U size. Okay. So we have a next. Why does it need a count? Why doesn't it count? Oh, it doesn't. Okay. Maybe this is not how you do it. Maybe this is how I do it. I don't know. So we have like a number of which like factorial we should compute, right? And on each iteration, we have a result. And we have a current, which is what it is. So this is what the return. This is what we return. So type item it's gonna be U64. And then the next function will actually return option item. Okay. So, what happens? If like current self current equals to self number, not equals, but like this. Return none. Otherwise, we return some. Otherwise, we do the following. So self current, we do it like this. And then we are going to okay, result is gonna be this. But what we're gonna return. So so result is 1, and it should be 1. And current obviously should be 0. Right? Current should be 0. I don't really wanna like multiply it before we return it, right? I'm trying to like make it kind of cute. But I don't know how. Can we actually make it like a constant in a struct? Isn't possible, right? Can it be like this? Well, you maybe can. Maybe not really. Okay, well, I'm untouched. But basically, the idea is we shouldn't change the number. Well, anyway. So. I mean, I kind of don't know what should happen, but like we could do it without return. We could do something like let them some self result, and then we do like this. Which is, I don't know, like how good of a solution this is. It should work. So what we do? We create, we do like this. Tutorial. And then we have a next. Position. Right. Okay. So it's option. But shouldn't really be. We should just drop it. Or should I accept? No method named accept. What? I mean, it's option, not the result, right? Oh, we could. I don't know. Just like this. Browser cannot convert usize to 64. Why is it usize? It isn't. Why it's trying to convert? I'm sorry. think I gotta know why though. Because position. What? Yeah, like this position. So to turn the index, we need that, we need actually, what we need is... what we need is... we don't need position... we need... so maybe next. I think next can accept a value... Can it? Can next accept a value? I can't find next. Should be there. Where's next? Provided method. Require methods. Okay. Next. And what should we do? Well, there should be a method that returns like it ends. Yes. So we need that. Are incorrect? How? Also, it's like this. Oh, but like, no, you should turn this. This is genius, right? No, not my explanation, like last. Why is, okay. But, so what is last return? Last, there's an option of item, which is U64. Okay. Only used. Okay, so we need like actually. No. We need. Yes. What's the issue? So, what happened? Failed all of the tests. How can this even be possible? The current is 0. So like it becomes like 1, and like 1 by 1 is 1. Sorry, 1 by 1 is 1. So that's not 2. What? I'll do it again. Do drive the back. Put there. I'm sorry. So do we get some kind of output? And how this is an issue? Like, I'm sorry. Maybe like I'm getting something wrong there. Maybe I'm... Wait, I think I actually... Okay, so... So what happens? We increment current. Well, we start at current is equals 0. And we should be able to return it right here and there. Okay. And we return the value every time. What do you do? Then what happens? I think like what we should do, we do like, let's see. Or do something like that. If else current, you're gonna just return. You don't do anything. Right. So how this gives us an error? I'm sorry. Else it goes so, of course. Okay. So there we just that. And this is just more clean, right? Just more clean. That's impossible. If we give it 0 and current is also 0. Factorial of 0 is 1, right? Like this somehow we don't trigger that. How it seems at least. It's panicked. It's panicked. How? How it possible? Oh, I think I know how. Because this. Because this. And still panicked. I don't get it. Also, I think we should do like match like self current. see this out. And then what we should do, we should use std. I forgot how I do that. We have all sorts. We have this. Return this. Oh, not this one. I need this. So if it's greater, return none. If it's equal, we just return it out. If it's less, we return that. Okay. Didn't exit successfully. But you exit on CPU. So, how can this happen? Can this happen? We created an infinite loop, right? Interesting. Also, like, can you create like an anonymous structure in Rust so we can like just inline that? So somehow it turns on a memory. How is that possible? Of current. Maybe like it's opposite. So if we compare 1 to 2, we get less. Okay. But if we compare like 2 to 1, we get greater. That's what we're trying to do, actually. So if current is greater than... It can't... how can this cause an infinite loop? I don't get it. I honestly don't get it. I just don't. Or maybe I actually did get it. Maybe I actually did get it. So, what happens? Is basically this happens. But then we need to then think about let me just go back to like the previous one. Maybe don't. Maybe not. Maybe don't go to the previous one. Can I call SMP? I can call SMP. So actually the SMP let's say select S. Okay. I should keyword never started. So it's an iterator. Okay. Look at that. Can we make it even more pretty? Well, I don't think we can. Or can we? Kind of maybe cheat a bit. I don't know if we should do that. Okay, let's check out the. So, I think like we just maybe wasted some time, but we did learn a bit of Rust. It's I think it's a win-win situation. We learned about iterators. Actually created one. Oh, never mind. So here, what it does. Oh, I see. I actually see. Okay, get it now. So we do this. Right. We do follow that. We follow this. There's a accumulate shit. Okay. So what would happen if fault I see now. So basically, if we give it 0, it's gonna be 0 elements. If we give it 1, it's gonna be 0 elements. If we give it 2, it's gonna be 1 element. So, for all the cases from 0 to 1, it's gonna return this. It's gonna return 1. Yeah, these are complicated. But I kind of get like how they did this. Right. So again, this gives us an error. Yeah, unused, whatever. The error is for like 2. Why? I'll give an error. We'll get an error for 2. And what's the error, by the way? So we get 1. Why do we get 1? Access 2. Access 2. I don't like how it works. Maybe like this or something. Okay. So here don't get any ECD out. Why? Why don't we get any? That's a good question, honestly. Because this should be like this. Product. What's this products thing? Takes an iterator, generates self from the elements by multiplying items. It's not gonna work. Yes, I see why. Okay, this was the selection. I would say it was hard, but say it was educational, you know. This was also, I think, like, this is just wrong. It's not gonna work. It's just not gonna work. You have an error. Oh, you can use equals. Oh, I see. I see. So you can. Good. Next one. I think we should be like trader experts by now. Let's define a simple model to track rustlings exercise progress. Progress will be modeled using a hash map. The name of the exercise is the key and the progress is the value. Two counting functions were created to count the number of exercises with a given progress. Recreate this counting functionality using iterators. Try not to use loops. So, what do we have? Here enum, and it has none, some, incomplete. We have a count for. So we get a hash map of progress. Okay. But what's that? Oh, I see. So basically, some exercises they have like some tests to give a value. So if it's like none, we count like how much nons do we have, like how much sum do we have, how much like completes do we have, and there we need to like use an iterator. Okay. Oh, I think it's actually pretty easy. So what we do is we do like, so we have a map, right? We have a map, and we can do that. Can we? No, method problem. We get an iterator. So what's interesting is we have like, I think, key value, right? Get a key value. And let's say this is gonna be what we need to do then is to filter. And then takes two arguments. Closure respects one argument, but takes two arguments. Oh, we need to do this. Can't compare. Well. Will this work, by the way? Nah, I shouldn't use that. What we should do is, we should do like... Or maybe we shouldn't. Huh. Yeah, so we kind of close. I don't know if iterator has a count. I mean, it should have count. Does have count. So the only like problem we have is like this one. We need to somehow do it. We need to compare. Can we just like this? To be honest. Or maybe we need to like do this. Don't need any of this crap. Oh, I get it. Like, basically, it's like, yeah, you don't need the key. Like, you don't need the key, basically. Maybe because of some kind of error. Implement the functionality of count collection for. Okay. But with an iterator instead of for. We have two functions. Why do we have like a count collection for? Because what's the difference? So collection is a slice of hash maps. I see. I see. I see. Wow. So we do this. Collection becomes a trader. Then the map. Or do we? Yeah, I think we should. Like flatten or something. Fold, no, not fold. This. Creates an iterator that flattens nested structure. Yeah. That's what we need. Turn off. Fuck, flat map. I see. How does this work? Okay. I'll just copy that. Easy. And they did what we did. Oh, it's actually, well, this is kind of smart because like we reuse stuff. But I guess whatever, right? Okay, so we have what? We have like 20-ish exercises left. Now we're doing with smart pointers. Okay. We have different ones. We have like C1, we have like arc. And we have like box. Okay. And we start with what? We start with box. So, compile time, Rust needs to know how much space a type takes up. This becomes problematic for recursive types where a value can have a part of itself, another value of the same type. To get around the issue, we can use a box. Smart pointer used to store data on the heap, which also allows us to wrap our cursor tab. Cursor tab are implemented in this exercise is const list. Data structure frequently found in functional programming languages. Each item in a const list contains, it's not a const, it's const, contains two elements, the value of the current item and the next item. Last item is value called new. Okay, so we have this. It's enum. Well, and it says that basically it says recursion. So to like create an enum, it needs to know the size of this type. But we don't know the size of list because it's not yet defined. We need to do this. Makes sense. This is all we have to do. We need to create an empty list. Yeah. An empty list is gonna be just what's gonna be just right. What do you mean like non-empty? Can I put anything into it? Well, one. Then we can put like another one, like two, three. I make a mistake somewhere. Oh yeah, two. Oops. What we basically need to do is kind of need to do this. Or maybe let's like let item third equals to let's actually read something exercises. Contains more partners with me. So using box J. Okay, so I'll use it. Oh, it's nice. Nice to know. It's like this should show us. Okay. Then it gives us an error, and so this is kind of what we want to do, right? So it's gonna be okay. So we need to also close this. And at last, we need to do this. Good. Okay. Next one. So RC is a reference count. Exercise want to spread the concept of multiple owners via the RC type. This is a model of our solar system. There is a sun, time, and multiple planets. Planets take ownership of the sun, indicating that they revolve around the sun. So we have a structure, it's sun, and like we have basically have an planet, which okay. We'll create new planets. Sure. What's the issue there? Oh, should I create a new? Should I just clone our sun? Should have like one sun, right? So, what happens next? Okay. Report. We have Saturn, Uranus, and Neptune. So we drop Saturn, drop Uranus, and we drop I get errors on all those. Yes. Oh, I see. Because we did already drop them. Some of them we didn't. So that Mercury, yeah, Mercury. Also like Mars, drop Mars, and it's like Venus. Did we drop Venus? No. Okay, you have the last one. Jupiter. We did drop the orb Jupiter. But what about Earth? No, we need to drop Earth. No, okay. Okay, what's an air? So we had like RC counter before. I have this. In this exercise, we're given a vector of unit, not units, sorry, science 34-bit integers called numbers, with values ranging from 0 to 99. We would like to use this set of numbers with within 8 different threads simultaneously. Each thread is going to get the sum of every 8th value with an offset. Sorry. Kesa. First thread, the sum 0, 8, 16. We have what? We have 8 threads. We have like 100 numbers. Okay. So Each thread should own a reference counting pointer to the vector of numbers. But like RC isn't thread safe. Therefore, we need to use arc. Okay, the fuck is arc? I mean, it's reference counter. I know that, but what A stands for? Oh, it's like atomically reference counter. See, right here. Yeah, atomically referenced counter. Okay, so what we do? We need to create a new atomically referenced counter for numbers vector. I'm going to type this, of course. And we have mutable, yes, join handles. Okay. So what happens? So I spawn threads, okay. And we iterate over these numbers with an offset, which is this. But each thread should have its own reference count. Should be atomic. Gonna be it's gonna give us an error. I don't know why, but first I wanna do this. I wanna name like numbers. And we should give it a reference range. Okay. Yes, well, that makes sense. Next is cow. What's a cow? This exercise explores the cow clone on the right smart pointer can enclose and provide immutable access to borrowed data and clone the data lazily when mutation or ownership is required. TAP is designed to work with the general borrowed data via the borrowed trait. Didn't understand anything. So we're trying to tell us that let's clone on the right smart pointer. Which means so it clones the data when we mutate it. One occurs because input needs to be mutated. So here we have vector. We create a call smart pointer for the function. So what happens? So what we do there? We basically do that. smart pointer. So just probably use that. Okay. Okay. No clone occurs because it doesn't need to be mutated. And it has variance borrowed data. Owned. It's owned data. I see. So I see. Okay. Reference no mutation. Owned no mutation. Owned mutation. Assert, which is also pass vector dot. Okay. A mutation occurs. Okay. This should be like this 10. It should be owned. And they should be owned. This, by the way, should give us an error. Yes. Okay. And now we start on threads, but I think we should do it on the next time. Okay, so see you later. Thank you for watching.